In video 1, we learned how to correctly name and label the sides of a right-angled triangle in relation to one of the acute angles. And we discovered the three trig ratios: sine, cosine, and tangent, or sine, cos, and tan for short. We also learnt a useful acronym and mnemonic to help you easily recall the ratios. And we saw examples showing the different ways you might be expected to represent these ratios. If this is all new to you, you might benefit from watching the video before continuing here. In this video, we focus on the trig ratio buttons on your calculator, looking at what they do and how to use them. Remember that the whole point of the three trig ratios is that for an angle of given size, such as 30 degrees, the values of the trig ratios do not change, no matter how big or small the right triangle is. Well, all possible values of the ratios for all possible angles are stored in these three buttons on your calculator. For example, tapping the sine button, followed by 30, and then equals, gives us 0.5, telling us that the sine ratio for 30 degrees is exactly 1/2. By the way, it's very rare to get an exact value like this, as you'll see soon enough. The significance of this value is that in any right triangle with a 30-degree angle, the ratio of the side opposite to the 30-degree angle compared to the hypotenuse will always be 1/2. Once we know what a ratio must equal, then we'll be able to determine a missing value, such as the height of this tree. We learn how to do this for any angle with any ratio in the next video in this series. Before we can do that, we need to know how to use these buttons correctly. Firstly, be aware that there are other units besides degrees for measuring angle size. You won't need them unless you study higher levels of mathematics, so we will stick with degrees. However, you do need to make sure your calculator isn't accidentally set to use one of the other types. So it's a good habit to get into whenever you want to use the trig ratio buttons that you check the screen here and make sure that it has a D or DEG or something similar to say that it is set to degrees. You might need to refer to the instruction manual if it's not clear. If it's not set correctly, you would likely see an R or a G or something similar. On most calculators, it's easy enough to change. I will demonstrate on this Casio calculator, but again, you might need to refer to your instruction manual. The mode button here has setup written in bright yellow, which matches the color of the shift key. Any key functions written in this yellow require you to tap the shift key first and then the required key. Pressing shift, then setup, we see this screen. Numbers 3, 4 and 5 in this list are the various units for measuring angle size. We simply press number 3 and the calculator will be set to degrees. This is vital, otherwise you won't get the correct ratio values when you type in the angle size in degrees. So always take a moment to check there is a D here before doing any trigonometric calculations, especially in an examination, because all your answers will be wrong if this isn't set correctly. Now we are ready to look at some examples using these buttons. In example 1, we are simply asked to give the value of the various ratios, rounding the answer to 4 decimal places when appropriate. Pressing tan, then 40, and equals, shows us that tan of 40 degrees equals this value. Be aware that most calculators will round the last displayed digit, so it's best to ignore it if writing the unrounded value. Good practice is to show the calculator's unrounded answer and then your rounded answer. Like any measurements used in calculations, it's important to show your units in your working. Notice that I've written the degree symbol. So the tangent ratio for 40 degrees is approximately equal to 0.8391 when rounded to 4 decimal places, as requested in the question. For interest, Here is the answer when the calculator is set to the units called radians. It's very different, so you can appreciate why it's so important to check. Try this one on your calculator. We were asked to find the value of the cosine ratio for 80 degrees, that is, cos 80. Rounding to 4 decimal places, we have 0.1736. In example 2, we are given some calculations to complete. We will need these types of calculations moving forward in the next video. The good news is that most calculators will allow you to type exactly what you see, other than the parentheses always being around the angle. So, typing 5 sine 70 gives this answer. It's best to close the parentheses, as we will soon see. 5 sine 70 really means 5 times the sine of 70 degrees. So we can type it in with the multiplication sign, like this, if we prefer to do so. I have rounded the answer correct to 2 decimal places, as stated in the question. Example 3 requires division, asking us to calculate 20.3 divided by the tan of 14 degrees. We can type it exactly as it looks, and here is the answer from the calculator. This time I have rounded to 1 decimal place. When the required accuracy isn't specified, a good rule of thumb is to use the same accuracy as the information provided in the question, and 20.3 has 1 decimal place. Keep in mind that divisions can also be written as fractions. So this expression is really the same question. As you can see, we get the same answer from the calculator when using the fraction key instead. It's important to make sure you close the parentheses, especially when following with further operations. Otherwise, the extra calculations will apply to the angle before the ratio value is determined. Consider our earlier example. Multiplications can be done in any order. So 5 times sine 70 is also the same as sine 70 times 5. And you'll get the same answer, providing you remember to close the parentheses. Otherwise, look what happens. The calculator has calculated 70 times 5, which equals 350, and then worked out the sine of 350 degrees. See, it's the same as typing 350 in for the angle. That's an angle that doesn't even fit in a right triangle, and you can learn more about that if you study advanced mathematics in your senior school years. I recommend keeping mathematical operations out the front, like before, where possible. At this point, you are ready to learn how to calculate missing sides in right-angled triangles, which we will do in the next video. But let's round this video off by looking at the second function on these keys, the functions written in yellow, and thus needing the Shift key to access them. You will learn more about them in the fourth video, but for now, it's useful to know that these functions tell us which angle a particular ratio must have come from. Let's return to our exact value example where we found that sine of 30 degrees was 1/2. Let's say you didn't know this, but you were looking to have the opposite side exactly 1/2 of the hypotenuse, and you wanted to know what angle would give you that ratio. Knowing that opposite over hypotenuse is the sine ratio, we can ask our calculator to find which angle it is. Tapping the Shift button, then the sine button, gives us this strange looking expression. It looks like sine has been raised to the power of -1. This is known as inverse sine or arc sine, or even sine to the -1. If we then type 0.5 after it, we are basically saying to the calculator, please tell me which angle has a sine ratio equal to 0.5. As before, it's best to close the parentheses and then press equals. There we have the answer, 30 degrees. We could also have typed it as a fraction, 1/2, if we prefer to do so. More on these second functions when we get into them in a later video. In the meantime, make sure you join me in the next video as we start to use what we have learnt to calculate unknown sides in right-angled triangles.